Hi, my name is Akshay, and in this presentation, I will be talking about my thesis titled Applying Machine Learning Methods to Predict Taxi Pickups Using Historical Taxi Data. This thesis was done at the company SEML in coordination with Aalto University. Let us take a look at the agenda of this presentation. First, I will give a brief introduction on why this thesis was done and what the problem statement is. Then we look at the three machine learning components, that is the data, the machine learning models, and the loss functions. After that, we discuss the results and then we conclude with the conclusion. Finland has a lot of traditional cab hiring / taxi companies. If you look at the city today, even Helsinki has at least 3 or 4 taxi companies that are run by big or that are run by taxi companies, and you will see the taxi logos put on their taxis. And these companies are now facing a lot of competition from the newer taxi companies that are based more on app-based calling of the taxis, etc. For example, Uber has now resumed operations in Finland after facing initial backlash due to the taxi laws. The taxi laws were recently changed in order to help individual drivers to run as taxis as well. Then so when these traditional companies face competition from the new companies, the taxi drivers want something more from the companies. They want to know where they can go in the city so that they can get a pickup. It's something that they want to do. And since the companies have the data, historic data, this is something the companies can use against the newer companies that are coming in order to be able to help their drivers to use the data that they have of the historical trips to help them predict or know where the future pickups will be on a given day. And the company where the thesis is done is a B2B company which provides taxi backend and related services and does not run its own taxis. So this services is provided to multiple taxi companies in Europe, and this would be a nice way. It's a nice software solution to provide the business taxi partners to help them improve as well. The company can add machine learning solutions to its portfolio of solutions that they can provide to the taxi companies. Let us take a look at the problem statement that we will be solving in this thesis. First, we would like to implement and evaluate various machine learning methods to predict the taxi pickups in the city for a given hour of a day. Then, we want to visualize these findings so that they can be used by the taxi drivers and dispatchers when necessary. The first component of the machine learning problem, the data, is provided by a business partner, a taxi company that runs its taxis primarily in the city of Mikkeli, which is about a few hundred kilometers north of Helsinki. The company also operates in and around Mikkeli in Jyväskylä and Kuopio, but for the sake of this thesis, we will be ignoring the data outside of the city of Mikkeli as the data is not enough. These taxi ride records have been collected mostly manually since 2013. The process of this data collection is just that a customer calls up the taxi service where a taxi dispatcher picks the call and then takes down the pickup location of the taxi customer and then dispatches a taxi to that location. Since this data is collected quite quite manually, and it is quite accurate. The taxi pickups written as addresses are quite accurate. But the issue with this data is that the data has been collected uh, only for the pickup addresses and pickup time. There has been attempts now to collect GPS information from the taxis, from the taxi sensors, but since the data that is collected of the sensors is too less and it's very recent, we will choose to pick up the meaningful data points from the data set that we were given with. In that, we will take the pickup time and pickup address, which is the textual pickup address. And these textual pickup address were converted into GPS coordinates using Google Maps geocoding APIs. In order to use this data for a machine learning problem, we will be clustering the data based on both the location and time. First, we will cluster the location data into grids called geohashes. These grids are a textual or a textual representation of a location. Now, why we use geohashes is because converting a location into a geohash and the vice versa is pretty fast. The geohashes also are very similar to the taxi zones that generally taxi companies use. There were other clustering methods that could have been considered. For example, KNN clustering, which is very common for such data. But KNN clusters created were too concentrated in the center of the city, and the nearest neighbor clusters would be too sparse towards the outside parts of the city. Although experiments with it gave decent results, it would not be feasible to use for a taxi company to show where zones of pickups are. We also tried DB-scan hierarchical clustering, and it was the similar result as well. And because of this clustering, we have created the pickup count, or the number of pickups for that cluster, as a label, and then we will continue to use it. In the image, you can see how the geohashes have been created, the small blocks, square grids that you can see. The pickup times were clustered into bins of 1 hour each. And here there were two different methods of taking the features. One was just to take the hour, day, and the weekend numbers. The other method was to try something different to make a cyclic representation of time, because if you take the example of an hour, 0 and 23 are supposed to be next to each other, but numerically it is not represented so. So we took the advantage of the cyclic features of sinusoidal waves, and that is how we also represented the time, that is the day and the time, as a circular representation. This gives us three different feature sets that we have used in the testing of this machine learning model. So first feature set has only the day and the hour as the specific features. In the second feature set, we use the cyclic features that we just converted, that we just spoke about, as the features. And in the third feature set, we will use the full features, including both types of time binning. The second component of a machine learning system is the machine learning model. In this, now we will look at all the machine learning methods used in this thesis. Polynomial regression was applied to the data just to have a feel of the data, and nothing more than that. The main methods used were the decision tree based methods, which we will. The first one is the random forest regression. A random forest works quite simply by creating multiple decision trees in parallel, where each decision tree is trained by taking a random piece of the dataset. Now, when all of these individual decision trees are trained, the random forest model takes the regression decision by taking a mean of all the decisions made by these individual decision trees. Now let us look at how gradient boost is different. What gradient boost does is, instead of building multiple decision trees parallelly, what it does is it first builds a decision tree which is a very weak learner, which has very less number of depth, and then improve on that decision tree by introducing another weak learner decision tree. Now this process continues, of course, till the hyperparameters, or till the parameters you have given as the number of different estimators for the different decision trees that you have built. And a gradient boost takes the decision finally from the final decision tree it builds. The XG boost is not much of a different algorithm, but it's more of an implementation by a group of data scientists, which makes all of these decision forest machine learning algorithms to run parallelly, and also they have some optimizations which we will see as they use a higher order derivative of the loss functions to improve the performance. And it's also used because it's become a very popular machine learning method, because a lot of these machine learning competitions, usually the winners have used or trained XGBoost to some level or the other. And at last, we also try to implement an artificial neural network model. It's a simple multi-layer perceptron with 3 or 4. We will 3 or 4 hidden layers and a single input and output layer. Okay, multi-perceptron perception is, or basically an MLP is modeled after the human brain, where the input is given and it passes through multiple stages of neurons before reaching the final output. This is, of course, trying to mimic the brain, which is what an artificial neural network is. The third component of machine learning system is the last function, which is used for training. We will be using RMSE for training all of our models, except for the MLPs, where we will be using an ADAM optimizer. The evaluation metrics we will be using for evaluating the results are RMSE, mean absolute error, and mean absolute percentage error. Mean absolute percentage error is quite popular, or quite common to be used when dealing with location data, and it gives a better picture it gives a good picture of how accurate the model is compared to other models. Then we will be tuning the hyperparameters using grid search, and obviously a bit of trial and error to find some good parameters, and then grid search to find the best parameters. And we have also used a 5-fold cross validation to make sure that the models are work throughout all across the data. We will now see the results of each of the machine learning models that we discussed. Random forest seems to be performing the best among all the models. In general, all the decision forest models performed very well. This can be attributed to the fact that all of them, the gradient boost, XGBoost, and even the random forest, are very robust machine learning methods, and which are capable of finding good good parameters to have decisions. We will be seeing in the next slide as to how the decisions were made. The MLPs failed to train well. This is again, this is a drawback that was sort of expected because of the kind of data we had was very small. Not very small, but it was not small, not big enough for the artificial neural networks to actually take into effect. And then the other takeaway is that we tried to encode the time and day as a cyclic feature, assuming that it would make a difference, but it looks like it did not really make much of a difference to any of the machine learning methods. Looking at the feature importance of each and every decision tree methods, because decision tree methods give you the importance of each feature that has been used for training. In the first feature set, where we used only the hour and the day of the week, this is actually very interesting to see that of course the latitude and longitude are important in making the decisions, but for the XG boost, which is weekend has the most importance there, which is quite surprising, as you will see in the next slide, that weekend is completely lost importance now, because when there is more features such as with date and time, day and time, the again you see the features being quite similar across the three different decision trees, where latitude and longitude being the most important, and then you have the time of the day and which day it is of the week. Even for the feature set 3, where all the features were combined, the results are quite similar. Longitude and latitude being more important, and in fact longitude being even more important than latitude, because the city stretches long along the longitude, so that's also looks like taken into consideration. We will just have a visualization of one of the results. This is on a Monday morning at 8 a.m. to see where are the probable taxi pickups. I just have a small image there on the right side, which is zoomed in of the city center. As you can see, the city center has a lot of taxi pickups relative to other places. And yeah, this is the visualizations that we thought we would do in the beginning. Now let us conclude by saying that we were able to make the machine learning models that could predict the pickups. It worked quite well with acceptable accuracy. These models were also used to make the visualizations of all possible pickup locations and pickup times. The drawback or the learning was that the artificial neural network methods did not work well. This again can be included in the further work, where the data collection can be improved much better. The pickup and drop off locations can be collected much better, because right now it is only the taxi dispatcher records that have been useful, but using the GPS sensors of the taxi can be very helpful. This is another real interesting feature or interesting future work that can be done, is to integrate machine learning models from different taxi businesses or taxi partners that our company works with, because this would be a very interesting machine learning challenge that also the big data team in the university that was also looking at it. So that is where I was motivated to look at it. And yeah, this is the end of my presentation. Thank you.